In this video, I'm going to be solving two of the more advanced power questions. These are at the upper level of what you'll be given in the HSC. So to start with the first one, we're going to look at the 2010 paper, and we're looking at question 13b, part I. And what we're looking at in this situation is we have a bicycle, I think. We have a motorbike that has a mass of, we're given a weight of 1700 newtons. I've written it as mg rather than w, which is what's given in the question. We're given a velocity of 30 kilometers per hour, and we're told the slope is 20 to 1. Now, in this situation, they haven't told us any friction, and so if we don't know what friction is, we have to then assume that our friction force is going to be 0. So in our situation here, what we need to do is we need to figure out, well, what's our formula? They're asking us to calculate the power required to maintain a constant velocity of 30 kilometers per hour. So in our data, I'm actually going to do data over here. Okay, so in my data here, what we're going to do is we're going to say, well, power equals work divided by time, which is equal to force times displacement divided by time, force times displacement divided by time, or FV, find the power FV. So given that from what we're given, we are probably going to use this formula here, power equals FV. So the thing that we need to look at is that for this F is actually going to be composed of two different parts. So in this case here, our power is going to be our friction, which is 0, and then what we sometimes call Wx, and that's a bit of a complicated concept. So what we're going to do is we're going to draw this up first. It's a little bit steeper than I would have liked. Okay, so if I've got a box, this is theta. In that case, what I have is I'm going to have a combination of forces that look like that. So this is my weight, or mg. And if I give this a common thing to do, normally we would worry about vertical and horizontal, but sometimes we might create our own coordinate system that looks like this. We might have x and y. And in that case, what we can call this is we can call this w in the x direction and w in the y direction, weight in the x and weight in the y. The only problem is because we have w for work and w for y, we'd rather call that something else. So that's why I don't use work earlier, I called it mg. So what we're going to do instead is we're going to use the angles. Now, we know that if this is theta, that this is also going to be theta. It's going to be the same angle. And so what we can say here is, well, is this adjacent or is this opposite to our angle? This is opposite, so we're going to use sine. So that's going to be mg sine theta. And that's going to be mg cos theta. Now, in this case, they haven't given us a theta. We could calculate the theta, and that's not particularly difficult. We could calculate the angle, and we might go through this process calculating the angle, doing it that way. But before I do it that way, I'm going to show you a different way of approaching this way of finding what values are. But the thing, what I'm going to get to is, we have a force, this F here. This F is actually composed of two separate forces. So our F in that equation here is equal to our friction force plus or minus what we sometimes call Wx. But if we don't like to use Wx, we can replace Wx instead with a more consistent term, which is mg sine theta. Now the problem is that sometimes we're not given a theta, and we might want to calculate it, and for most students that just might be more intuitive, just to use your tan function to find your theta and then just calculate it that way. Now the point here is that in the case of our vehicle, we're accelerating up the hill, so it means that we're going to have, if that's our velocity, it means we're going to have friction. Friction wants to prevent movement, so if we're moving up the hill, friction is going to be working to prevent that. So in this case, we have the weight of the vehicle is causing us to roll down the hill, and friction is also pushing in that same direction. So these two things are going to add together. We're going to have the weight of the vehicle and the friction. Now in this case, we haven't been told the friction, so we're going to say 0 plus mg sine theta. Because if they haven't told us what the friction is, we can assume it's a frictionless surface. Or we can assume that the friction is trivial, like it's not going to be significant compared to the weight of the vehicle. So the question then is, how do we get this value without calculating theta? And why would we want to? Well, just because often it's just considered to be fairly easy. So what we're being told is that this ratio here is 20 to 1. That it goes 20 along the horizontal for every one that goes up. And that's going to be represented here as 20 to 1. Now, using some pretty simple trigonometry, Pythagoras' theorem, what we're going to say is that the hypotenuse is going to be equal to 20 squared, which is 400, plus 1 squared, which is going to be 401. So this area is going to be the square root of 401. So hopefully if you've got that level of Pythagoras' theorem. The thing is that when I type that into the calculator, the square root of 401 is a pretty small number, it's pretty close to 20. Effectively, we can just use 20 as our answer. 401, which is equal to 20.02. Now, what you'll see if you look at the HSC answers for this is that they've actually written that, and this was confusing for me. When I first started teaching, I'm not a mechanical engineer, so I hadn't really done these sorts of questions, and I was learning this as well. And it wasn't in the, I don't remember it being part of the course when I did it 20 years ago. So we know that our mg is equal to this, and it writes the answer as mg divided by 2. But what I find is it doesn't actually give you that answer. The answer that it gives you is not that when we look at it. It really shouldn't be mg divided by 2. So there's an error in the HSC answers. What we should actually be doing is, what we want to say is, well, if we know that we've got similar triangles. If we have similar triangles, and we've been told that this one is going to be 1700, and we know that this is 200.02, well, this is going to be the same as 1700 divided by 20.02. Or another way of writing that is you could write 1700 divided by square root of 401. But you're actually allowed to just use 1700, it's not very good, 100, divided by 20. You're allowed to use that value. So you have some different choices there about how you approach that. So we're going to type in that answer and we'll see how we go. So what we get is 1700. We're just going to write divided by 20 because we know it's close enough, and we know that the HSC didn't even come close to showing us that right answer. But we're allowed to use, because it's close enough, and we get then our force equals 85. And once we know our force, what we can then do is we can go back to using by the power FV, and we can say, I'm now going to clear this off because I need a bit of space. We can then say that from there we can say power equals force times velocity. Our power is 85 and our velocity is 30 kilometers per hour. So like Ed Sheeran, we have to divide by 3.6 times 30 divided by 3.6 is going to give us a power of 708 watts. Let's check that that's... And that's the answer they give us in the book as well. They give 708.3, which is what I've calculated. So it's worth pointing out that in the HSC answers, they write this, but in fact they give that as the next answer in the line, and that's because we should be using 20, or more accurately, we should be using 20.02. So it's up to you. You will not get marked down if you just write 20. So that's one way of approaching it. That's a lot less work than the alternative. I guess what I'll do is I'll quickly prove that if we find the angle, and I'm like feeling really reluctant to do this, that if we find the angle we'll get the same answer. But for some people that's going to be how they approach it. So they're going to want to find this angle. So to do that we're going to use, our opposite is 1 and our adjacent is 2. So if I use 1 divided by 20, put it in arctan, we're going to get a very small angle, theta equals 2.86. And so from that, what we then will going to calculate is our if we calculate our ratios of forces, we're going to find our mg sine theta. I'm going to write this in red to show that's the alternative method. I should write that here. So arctan theta, arctan theta equals arctan of opposite over adjacent, which is equal to 2.86 degrees, not radians. Okay, and then our alternative method is to say that F equals 0. Oops, wrong sign. F equals 0 because we've not been given any friction, times 1700 mg sine theta. So sine 2.86. Okay, 17. And we get an answer of 84.8. And that's probably because I had some rounding. So that's another way to approach that question, but we still get the same enough answer within the rounding error that we might use. Okay, so that's our first question. We can clear that off. That was worth 2 marks. For the 2 marks, I wouldn't want to mess around with 10. I would just rather use 20, but I can understand why it's confusing for people. And if you're familiar with the idea of Wx, weight x, as being mg sine theta, that's probably going to be a way that some people are more comfortable solving this question. Okay, the next question, 3 marks. When I talk about friction questions being bears or boats, this is kind of the quintessential question. And what we have to do in this question, so in 2014 there was a question that had 2 questions, and in one case the boat was sliding down the hill. Now, if your car is going to slide down into, I don't know, lava, you're really grateful for that friction. If you're pushing the boat and sliding down, you're thinking, thank God for friction, because otherwise I wouldn't be strong enough to hold this bus on my own, or whatever, the boat on my own. But when you start trying to pull the boat, in this case, up onto your trailer, well, in that case, friction always acts to oppose movement. So if we're trying to pull this up onto our trailer with a winch, then in that case, we're going to have friction is going to be working against us. So the question asks the same thing twice, and it's really important you read the question to see, are you preventing sliding, or is the vehicle moving upwards? And if it's moving upwards, then friction is going to be working against you. So let's have a look. What we need to find first is we need to find the forces that are acting on this boat. So what is the tension that's going to be on this cable and the winch? Now, the fact that I said tension might be a bit of a clue that because it's a rope and tension, we've got a formula that simplifies. It's what we call the too many guys formula. So too many guys or girls, and we have sine theta plus or minus mu cos theta. There's a bit of a story. The idea is a mnemonic to help you remember this. I'm the only one who uses this version of the formula, but if it works for you. So the idea is that there were too many guys on the boat, and then as the person was leaving the party, they hit their head on the sign, and then they got sneezed on and they get covered in mucus. Right, that's the story. Now, the thing is, the HSC answers, it approaches it, it's the same concept, but they just write it differently. They just write it as being if I draw this boat again, so the forces acting on the boat, we have the weight. And remember that weight is always vertical and down, and it's always the hypotenuse. So that's mg, and then this one here is going to be acting down is going to be mg, because it's opposite the angle, it's going to be mg sine theta, and that theta will be the same as this, and this one will be mg cos theta. Now, we're interested to find friction. We're interested in F equals mu n, which n, because we know n is going to be equal to, it's going to be equal and opposite. The only forces, if we use if we have some of the forces in this y direction, sigma forces in this y direction equaling 0 will tell us, therefore, the normal force is going to be equal to this wy, the y value of weight, which we wrote as mg cos theta. And so in that case, our friction, when we substitute n using that value, we're going to get friction, and I'm going to write that with a little f, friction equals mu times brackets mg cos theta. And then, in addition to that, if we say in the y direction, well, we have three forces. We have the tension on the rope, we have the friction that's resisting that, but we also have the weight, the Wx value that's pushing, the weight x that's pushing this thing down. So effectively we have the tension is going to be equal and opposite to mg sine theta and friction force. So let's write that in here. So we have our tension is going to be equal to our weight force, which is mg sine theta. That's the weight component of sliding down the hill. In this case we're adding because friction's working against us, so it means we have to deal with both of these forces, mg sine theta, and then we also have friction, which we've said friction is equal to mu times the normal force, and the normal force in this case happens to be equal and opposite to the vertical, the y value of weight, or wy, which we prefer to write as mg cos theta. And you can see how we can then expand that bracket, so we can factorize that bracket to write it as mg sine theta plus or minus mu cos theta. It's the same concept, it's just another way of approaching it. Okay, so we've now found our t, we're going to find our t rather. We're going to say, I'm going to use the too many guys formula. Now that I've proved that, I'm going to say it's slightly, yeah, the HSC, their answers don't use the too many guys formula. So I'm going to use that one though, because it's slightly faster. Okay, so I've got 13,000 newtons, right, when I multiply, it's 1.3 tons multiplied by 10 for gravity. And then I've got, it does change your answer a little bit if you multiply by 9.8, but by 10 is fine. And then I'm going to say sine theta, so sine, and it's 20 degrees, plus mu, which is given as 0.3 times mu times cos 20 degrees. Okay, so how do I type that into a calculator? Well, I start with the most complicated part. So I'm going to say 0.3 cos 20 degrees equals 0.282. And then I'm going to clear and then do sine 20, which is 0.342. If I add those two numbers together, the number, so I'm going to do plus answer, equals 1300 times 0.624 times 13 is going to equal, so the answer is actually giving their answer in kilonewtons, so we'll do the same. Yep, right, kilonewtons, that's the same as the book. If you notice a jump, that was because I wrote down 0.28 instead of 0.62. Then, so we've got tension, and so then we're going to say that, well, P equals Fe, fight the power Fe. This T value is going to be equal to that F. So what we have is our power is going to be equal to 8.14 times velocity, which is already given in meters per second, but be sure to check that. So if we multiply that by 0.7, we get P equals 5.67 kilowatts, because we're in kilonewtons. And then the last thing is that they've then asked us to, so this brings all three of our fields that we were interested in together. This has friction, this has power, and this has efficiency. So it's actually quite a good question. And in this question, what it's going to ask for is it's going to say that calculate, we've been told the efficiency, so now what we need to do is we need to figure out the power that's been applied into the motor. So we know that the output of the motor, so we know that efficiency is equal to output divided by the input of the motor, right? You can't get more out of the motor than what you put in, but you can get less than what you put in, and that's because of efficiency, which is equal to 77%. So another way of saying that is that if this is what we're getting out, then what we have to put in has to be bigger than this. So if we've got a number like 0.77, we're going to have to divide by 0.77 in order to get a number that's bigger. So we're going to say that, in that, rewriting that, so we're going to say our power that was the input is going to equal the power that was the output divided by our efficiency, which is going to equal 5.67 divided by 0.77 divided by 0.077 equals 7.37 kilowatts. And let me just check. That's what we get in the HSC as well. Okay, so they're probably the toughest questions that I will give you in a half-yearly or a mid-course review or a trial, and that should give you a pretty good idea of what you need to do. There are some harder questions in the Copeland book, but they're probably extension and they're not really representative of what you're likely to see in the HSC. Okay.